Well, hello, folks. I'm happy to be here. I am James Bach. I have been asked to talk a little about the test methodology that I've created and that I teach. It's called Rapid Software Testing Methodology. And this is a methodology for testing any software on any project ever. It's for embedded systems, it's for medical devices, it's for video games, it's for e-commerce, it's for testing anything. And yes, I became well known in the mid-90s because I was talking about exploratory testing. And I would say now, today, that all testing is exploratory testing to some degree. That one of the big misunderstandings about exploratory testing is that it's some special kind of testing. It's the most normal kind of testing that there could be is exploratory testing. So maybe I'll say a little more about that later, but I've got some slides. I want to go through them just to talk about how rapid software testing is, what its focus is, why it's a little different than other methodologies. You'll find I am not a fan of the ISTQB. I believe it's a scam. I think they want your money and they don't give you anything in return that you couldn't have gotten for free on the internet. I don't sell certifications because I can't think of any way to sell a certification that is honest and also is economically viable. I can certify people, but it would take me like a year of watching them test in order to certify them. So I don't even attempt to do certifications. Instead, I try to help people become excellent testers. And by that, I mean people who can systematically find good bugs in software. All right. Well, let me get started with my slides here. There we go. Here we go. Okay. Well, a lot of methodologies want to focus on tools, templates, rules. I don't think that's where the value is at. Tools are interesting. Templates sometimes are interesting. Procedures occasionally have some value written down, but that's not what my methodology focuses on. My methodology focuses on the craftsman, this guy. If you want to do excellent testing, you must develop yourself into a skilled tester. It's testing skills that matter. Everything else, any documentation, any rules, any pictures, any templates, any tools are all supporting the guy in the center. Rapid software testing focuses on the tester, not test cases or anything else. It focuses on the tester. And then it's test cases. It's that we don't think that they're the center of testing. The center of testing is the tester. That's a fundamental philosophical position that we take. People are the center of everything. And no, I don't think AI changes this, in case you're wondering whether AI means that people are no longer the center. AI is a tool. AI is incapable of taking responsibility. In rapid software testing, the central focus is always what we call the responsible tester. That is the tester who takes responsibility for the quality of the work. If you do not have a responsible tester, then it's like a car with nobody driving it. And I know some of you are thinking, well, there are self-driving cars. There really aren't self-driving cars. I'm afraid there aren't any self-driving cars. There are cars that claim to be self-driving, but they're not really self-driving. No self-driving car is capable of taking responsibility for its own actions. And so it can't really be self-driving. Responsibility is a core concept. It's a core ethical concept in society. Imagine society where people didn't take responsibility. You couldn't have a society. You couldn't call it a society if nobody takes responsibility. It would be a jungle. It would be endless war. It wouldn't be a society. The beginnings of society, of human society, is somebody takes responsibility. Somebody makes a promise to somebody else to grow food or obey a law or make a law or build a house. Somebody takes responsibility. And so that is the core of rapid software testing. Somebody taking responsibility for testing. And then we go out from there. What does it mean to take responsibility for testing? What kind of skills must you have to take responsibility for testing? Now, this contrasts with other methodologies, which are based on what they call best practices. If you think about it, a best practice, it's not a person. It's this idea out here. It's this impersonal thing. And we're supposed to revolve around that impersonal thing, that principle or that practice. And I think that doesn't work. I think it's never worked. So there's no best practices in rapid software testing. There are people, there are heuristics, there are dynamics, there are problems and solutions. That's what we have in rapid software testing. A reason we don't have best practices is there are no best practices. There is no practice that anyone can point to and say, that is the best possible thing that anyone could ever do. And even if they could say that, and there are some people who want to say that, they can't prove it. All you're going with is that person's opinion. So it comes back to the person, the authority of that person, the skill of that person. Anytime I feel like saying best practice, I just leave the word best out and I just say practice. I say, here's a practice. Here's a practice I like. Here's a practice I'm excited about. Here's my favorite practice. Those are all very reasonable things to say because those are all references to a person. And it is the personal reputation, personal skill, personal authority from which everything else flows. It doesn't matter whether you're a doctor, you're a lawyer, you're a politician. It all comes back to personal honor, personal skill, personal responsibility. All society is based on this, and rapid software testing is based on this. So I'm not going to suggest that you create a bunch of test cases and then you point at the test cases and say, it's not me. It's not me doing the testing. It's these test cases are doing the testing. And then hand the test cases to someone who doesn't understand them and say, run these test cases and everything will be fine. Everything will not be fine because that next person will not understand the test cases. And so they will not be able to take responsibility for the test cases. The main process by which we achieve excellence in testing, according to my philosophy, is not through a process of programming people as if they were little computers, but through a process of growing them as if they are a garden, as if they are living things, because we are living things. There's something called a wildlife garden, which is a certain kind of garden that is designed to attract wildlife. A wildlife garden. The gardener in this case is a steward for life, but not someone dominating that life. And when I teach testers, I teach in an anti-authoritarian way. I'm not looking for obedience. I'm not interested in obedience. I can't use obedience. I'm interested in people's agency. I'm interested in people using their mind. So I'll take the most junior tester, someone who's never tested before, and I tell them very little at first about testing. Instead, what I do is I give them a testing problem and say, solve it. I say, here's a product, find a bug in it. And they go, I don't know how to test. And I go, I know you don't know how to test, but try. Just try to find a bug in this. And I see what happens. And usually they can find bugs in the things that I give them. Sometimes they're totally paralyzed and they can't do anything. And then I show them something and they see what I do and then they try it themselves. But my belief is, based on the science of human cognitive psychology, my belief is that we're all born testers. Every child is a tester. And most of us cover up our testing skills when we become adults. And there's a very simple reason why. We're testers as children. We stop being testers in our teenage years because we learn how to get along with other people. And getting along with other people means you stop testing them. You start being friendly to them. So we put away our testing skills, many of us as adults. I didn't. I remained an unpleasant person throughout my teen years and into my adulthood. So I had to learn how to get along with people more than most people have to do that. I'm not naturally someone who likes to get along with other people, but I learned to do that. But my tester instincts were strong and stayed strong. And that's a big reason why I was attracted to testing and stayed in testing when I was first recruited to be in testing when I was 20 years old, which is almost 38 years ago. I was a developer in my teenage years, a professional developer. I worked on video games between when I was 16 to when I was in my the early part of being 20. So for about 4 years, I did video games. I was really burned out and tired of it. I didn't enjoy development. But then Apple Computer hired me to be a tester, and I thrived. I loved testing. It was such a match for how I like to complain about things, and I like to analyze about testing's perfect for that. So I still use my programming skills, which I've kept up and developed over time. I use my development skills in testing, but I have no interest in being a developer. So when I encounter a new tester, I see them as a person with certain talents and proclivities, and I try to develop them to be a skilled tester. And I don't do this by telling them to obey me and do what I say. I will invite them to try different things, different exercises. I'll tell them things and invite them to consider my words. But obedience doesn't ever come into it for me, because obedience is corrosive to the idea of competent technical work. Everyone who does competent technical work must do so based on their own convictions. I suspect not many of you have ever flown an aircraft. I come from a family of pilots. I have an expired pilot's license. My older brother's an airline pilot. My father was an Air Force pilot. My mother was a pilot. One of my sisters was a pilot. So I come from a flying family. And maybe you don't know this, but if you ever took flying lessons to learn how to fly an airplane, you'd discover that on the very first lesson, in the very first minutes of learning to fly an airplane, the instructor would put you in the pilot's seat, and he would sit in the co-pilot's seat. And from the very first minutes, you are controlling the aircraft. You are learning how to hold the controls, and then he has you take him flying, and he tells you what to do. Yes, but you are doing it from the very beginning, because pilots know that the way you learn to fly an aircraft is to fly an aircraft, not watching somebody else fly an aircraft, but flying it yourself and feeling that you are in control of the aircraft. The purpose of the flight instructor is to keep you from killing yourself and him while you're doing that. I teach testing in a similar way. It's all about building you up. So in rapid software testing, we talk about responsible testers, and their definition of a responsible tester is the person who is accountable for the test strategy. So if the test strategy is bad or wrong, this is the person who answers for it, is the responsible tester. There are supporting testers. Supporting testers help the responsible testers, but they are not responsible for the test strategy. And then there are test leads. Test leads work with the responsible testers and guide them. But the center of everything is the responsible tester. A supporting tester is not necessarily a junior tester. I have frequently acted as a supporting tester for one of my students, where I'm like the flight instructor in the co-pilot seat, and they are trying to be the pilot in command, and I'm giving them advice, but ultimately I'm letting them fly the airplane. If you are going to learn responsibility, you need three things. Well, you need freedom, wisdom, and responsibility. And Let me tell you what freedom is, because it may surprise you what my definition of freedom is. Freedom is the ability to hurt people. That's what freedom is. No other definition of freedom gets to the issue, the real heart of the issue. Freedom is the ability to hurt yourself or others. So if I put you in an airplane and have you fly it, you have the ability to take the controls and push them down and fly right into the ground and kill everybody. If I teach you to drive a car and I put you in the driver's seat, you can jam the accelerator, go as fast as the car can go, and you can smash through the wall of somebody's house, killing yourself and everybody in the house. That's the freedom that a car gives you, the freedom to do a lot of damage. But you take the freedom and let's add some wisdom to it. What is wisdom? Wisdom is knowing how not to hurt yourself and others as you go through and use your freedom. And responsibility, I say, is making the choice not to hurt yourself or others. So wisdom is knowing how to be safe. Responsibility is deciding to be helpful instead of hurtful. Now, here's the key thing. As every parent knows, you have to give your child a little more freedom than they have the wisdom to handle. And then they make little mistakes and they get hurt a little bit, but then they learn from that and they grow in wisdom. So we always give a little more freedom than the person can handle. And in this way, they make their own mistakes, but not mistakes that are too big if you're taking care of them as a parent. And eventually they can handle anything. I do the same thing when I'm teaching testers. I assign testers work that they don't know how to do. And I say, if you get stuck, if you get really stuck, you can send me a message. I'll help you get unstuck. And I have certain students who've been through this process and been extremely successful in it. Actually, one is here in this call right now. I will not embarrass her by calling her out by name, but she knows that I know that she's here. and that I'm very proud of her. And we've gone through this week after week after week after week. Problem after problem after problem after problem. Solving it, getting stronger, getting more capable, and growing. And it's my hope for every one of my students that they become my peers someday. And we have a straight across relationship, peer to peer. I tell every student, if you work with me, you're on the path to liberation. I don't need an army of zombies and slaves. I don't need people to obey me. What makes me happy, what makes me proud is to see leaders growing. And that really fits with rapid software testing. Because rapid software testing is all about using your mind. Someone has those. There we go. In rapid software testing, we distinguish between explicit and tacit knowledge. And both of them are important. Explicit knowledge is knowledge that you can write, you can speak, you can put into pictures. Tacit knowledge is wordless. It lives in your body. Lots of people have tacit knowledge of software testing, but they do not have explicit knowledge of software testing. That is to say, if I give them something to test, they can find bugs. But if I say, how did you do that? They go, I don't know. I just found the bug. And I say, well, what was that technique you used? And they go, what technique? I don't know what you're talking about. And then I'd show them what they did. And they go, oh, yeah. And I say, what do you call that? And they go, I don't call it anything. I call it testing. A big part of what I do in rapid software testing is I give words to tacit knowledge so that you can appreciate the skills that you actually have. To some degree, I'm teaching people testing, but in another way, I'm helping them realize all the things they already know about testing by helping them get some words for it. How you get people to develop tacit knowledge is not mainly by talking to them, although that can help. Mainly, you grow tacit knowledge through practice, shared experiences, observing other people working, introspecting about that, and that grows your tacit knowledge. So rapid software testing is a mindset and a skill set. It is not a set of templates. It's not a set of hard and fast rules. It's not an algorithm. It's a way of thinking about testing. And it's a set of things you know how to do that you practice. I created this concept throughout the early 90s into the late 90s. The first time I taught a class called Rapid Software Testing was in 2001. And anytime you hear about rapid testing, you'll hear about Michael Bolton, my colleague in Canada. He started working with me in the early 2000s, and then he became what we call a principal author. He became basically my business partner in 2006. So that means any idea I have about RST, I have to check with him like he's my wife or something. So that he's happy and I'm happy. And any idea he has, he checks with me. And so our work is in lockstep with each other ever since 2006. He's my closest friend. I work with him almost every day on Zoom. And so whatever Michael Bolton says about rapid software testing, I completely endorse. And then behind the scenes, we might argue about it. But he teaches the class in person these days. I teach the class only online because since the pandemic, I've decided I don't want to travel anymore. I don't want to be on an airplane anymore unless a billionaire pays me an outrageous amount of money to go somewhere. I'm not going anywhere. I'm going to stay right here. So I teach the online classes. Michael travels. He's in New Zealand right now where he was just teaching the class live. And I think he'll be teaching in Romania soon or something. I think he's headed to Europe next. Okay, so here's our definition of testing. In rapid software testing, we say that testing is evaluating a product by learning about it through experiencing, exploring, and experimenting. So we say anytime that's true, that's software testing. Testing is always an evaluation process. It is always a learning process. And it always involves at least one of these three things: experiencing the product as a user would, or exploring it, or experimenting with it, running experiments on it. Within testing lives another thing that's very important, which is what we call checking. But we don't confuse checking with testing. One of the problems I have with the way that the whole industry talks about testing is they confuse the process of output checking with the process of testing. Output checking is automatable. You can automate checking the output of a program. You cannot automate software testing. People say automated testing because they don't really think about what testing means. To say that you can automate testing would be as outrageous as saying that you can automate parenting. Imagine asking a mother, are you an automated mother or are you still doing manual mothering? It would be an outrageous, crazy thing to say. Try saying that to your mother. See what her reaction is. Because to be a mother, to be a parent, it's not simply to perform some rote procedure. It's obviously much, much more than that. Testing is too. Testing requires social judgment, social competence, because every time we test, we have to decide, is this bug important or not? Is this testing that I'm doing right now, is it important to do or not? Maybe it was important and it's no longer important. I'm making social judgments all the time about how this relates to the user. How does it relate to my client, my manager, the project? That can never be automated because I have to understand the people and how these people feel about the situation here and now. I can't ask ChatGPT about it. It doesn't know. But yes, I can automate output checks, and I'm eager to automate output checks, and that's fine. It's just not testing. It's part of testing, but it's not testing. It's testing in the way that the wheels of a car are part of the car. But if you say, I'm going to go get myself a car, and then you come back with some tires, people will think, where's the car? And you go, well, here's the car. And you go, no, those are tires. Tires are part of a car. Tires are not the car. And yet people point at automated checks and they say, there are my tests. Those aren't your tests. Your tests are what happens when you run these checks and then you think about what it meant that you ran these checks. Are they enough checks? Did you run them at the right time? Did the right thing happen while they were running? Only a human can interpret the situation and say that that is true. So output checking is important, but testing is a social process, not just a mechanical one.